Hello geometry students, and welcome back to another video lesson as we continue to explore trigonometry. Today our focus is going to be setting up and solving trigonometric ratios so that we can find the missing side in a right triangle. All right, so we have to be able to set up and solve these trig ratios in order to find the missing side. Now, before we get there, I want to try a few warm-ups based on yesterday's video lesson. So if you would please take a few minutes to pause the video here and try to answer all three of those. Okay, the sine of A. So number one, if we're working at A, this is my hypotenuse, this is the opposite side, and this is the adjacent. So that's number one. We got to figure out the names. Now we have to remember this acronym. So, CA, TOA. Because this acronym helps us to describe what we're looking for a ratio. The sine of A. Sine stands for opposite over hypotenuse, or 7 over 12. The opposite over the hypotenuse. Where cosine of A, right? I'm still sitting here at A, so I can leave these all the same, but cosine is CAH, C-A-H, or the adjacent side, which is 5, over the hypotenuse, which is 12. Last, they want the tangent of C. So now these are no longer appropriate because I'm not at A anymore. I have to imagine that I'm down here at C. This is my adjacent because it's next to C, and this one's the opposite because it's across from C. The tangent refers to opposite over adjacent. So the opposite of C is 5 over the adjacent to C, which is 7. Right? Those are those trig ratios. That's where this information up here is super vital. Now, we also can look at these in terms of evaluating them. Okay, what are the values of the following to the nearest hundredth? You're probably going to have to use Desmos if you don't have a calculator for these. So let me show you the first one, the tangent of 45. When we are in Desmos, we want to make sure that it says DEG for degrees. If I accidentally clicked it, it was going to calculate it in something called radians, which is what we don't want. So we want the degree to be shown. Even if you're on your own calculator, make sure that it is in degree mode. So tan, I'm going to click the tan button and then hit 45, and it gives me a value of 1. If for some reason your calculator doesn't do that, you're probably not in degree mode. You're probably in this radian, which gives us a different value. So the tangent of 45 is 1. Tan of 45 equals 1. I don't have to round it because it was exact. Why don't you try B and C? All right, the sine of 75. So I'm going to go sine of 75, round it to the nearest hundredth, is 2 decimal places. So this 6, but the 5 after it makes it go up, so 0.97. Equals 0.97. And last, the cosine of 100. Let's clear that again. The cosine of 100, negative 0.17. Negative 0.17. And we're going to have to use a little bit of this information today as we are finding the missing sides. All right, so here comes the new stuff. In a minute. Let's review first, right? Let's make sure we know what SOHCAHTOA stands for, that it's these trig ratios in right triangles. The hypotenuse will always be the longest side, right? So it's always opposite wherever that right angle is. That's the hypotenuse. And based on which angle you look from, we also have to identify then the opposite or the adjacent. So sometimes we'll use this symbol, it's called theta, to represent which angle we are standing in or which angle we are looking from. If I'm standing at this angle, the one across is opposite and the one next to it is adjacent. If I were to switch, it changes my point of view, and those switch as well. But for this picture, remember then that the sine equals opposite over hypotenuse. The cosine of where we're standing is adjacent over hypotenuse, and the tangent of where we're standing is opposite over adjacent. Remember, this ties directly to these right in here. And it's those that we have to use to help us find missing sides. So as you can see in this picture, they want us to find this side labeled X. What we need to do first is to identify the relationship between this given angle, that's where we're standing and looking, and the two sides that they give us. Well, what would we call 97? Hopefully you answered adjacent, because it's right next to the 56. What would we call the side labeled X? That would be called our opposite side. So in this picture, we have an angle, we have an opposite side, and we have an adjacent side. Which trig ratio relates these? That would be tangent, TOA. Remember, so, ka, TOA. And we have labeled the opposite and the adjacent. And so we are going to have tangent of whatever angle we're using. I'm going to just put theta equals the opposite over the adjacent. And we're going to fill in the information that we know. It's tangent of our angle. But what angle measure are we using here? We are using 56. Equals the opposite side, which is X, over the adjacent side, which is 97. So there's our equation that we're going to work with to try and solve. If I want X by itself, what is the opposite of dividing by 97? It is to multiply by 97. Multiply by 97. And so we can say that X equals 97 times the tangent of 56. And we're going to go to Desmos and punch that whole thing in right here and round to the nearest hundredth. 97 times the tangent of 76. 97 times the tangent of 7. Why am I saying 76? Of 56. And we'll close it. So if I type it in correctly, look at what we get. 143.808. So the second 8 makes it become a 1. 143.81. And that is our answer. Okay, so we've got to go through this step. Whichever angle they give us, identify what names we would give to the sides that they're given and the side they're looking for. What names, and then identify which trig ratio, which one of those three relates all of that information, and then set it up so that we can solve. Why don't you take a minute and try this one on your own? All right, here's my angle. Right there, that's the angle that we're standing at and looking at. So what do we name this over here? 60. If it's across from that, that is the opposite. And what do we call this? X? Well, even though it's next to 38, we got to be careful because it's actually opposite the right angle, which means it's the hypotenuse. It is indeed the hypotenuse. So which one of our trig functions uses opposite and hypotenuse? That's sine. Sine of a given angle equals the opposite over the hypotenuse. So let's fill it in. sine of our angle. We know the angle this time is 38. So sine of 38 equals the opposite side, which is 60, over the x. Over the x. Now this one is slightly different, right? The x is in the bottom. When the x is in the bottom, essentially what's going to happen is that these two are going to switch spots. X equals 60 over the sine of 38. All right, let me show you why that happens. If I multiply, right, we want to get rid of x on the denominator. So I multiply by x and I multiply by x. I get x times the sine of 38 equals 60. Right? Because the goal over here on the right was to make sure that those two canceled out. Remember from earlier, though, that the sine of 38 is just some really weird random decimal. So to move it, I would divide by that random decimal. Or in this case, we divide by the sine of 38. And so what really just happened when x is on the bottom is that it switched places. Right? X equals 60 over sine of 38. It just switched places. We can type this into decimals if we do it carefully. All right, 60 divided by the sine of 38. So we're going to type 60, and then we're going to hit divided, and we're going to make sure it turns it into a fraction, the sine of 38. And we want to make sure we close the parentheses just in case. 60 divided by sine of 38 is 97.46. 97.46. So that's how we can use these trig ratios to help us find the missing sides. Identify what sides you're working with based upon the angle that's given, and then figure out which trig ratio you need to set up and work backwards to solve. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe